Welcome back, PlayBASIC coders. I was asked the other day about how you go about returning information back from a function called by call function. Now, call function gives us an ability to call a function by name. In this case here, I've got a handful of functions just called work function 1, work function 2, work function 3. Now, I'm never actually invoking these. I'm never calling them directly. I'm just randomly, well, not randomly in this case, I'm just running through and calling each one by name. I'm building the name as a string and then using inside the call function, it will actually look up, it makes a hash of it, finds where the function is, and then passes control to that like a normal function call. One restriction from this is that you can't actually return values from this. There's different mechanisms that are required, and at the time I just couldn't think of a way of doing it. Now, that doesn't mean you can't get data back. You could have in here you might have like a little a pop return or something like that to push some data onto your own stack and then retrieve it at the other end. But here's one way. You could have a structure of just, in this case, I've just made a structure, just call it tReturn. We have a data type field as an integer. Then we have our 3 possible return types. We've got, it might be an integer value, it might be a floating point value, or a string. If we follow one of these through, let's say we run the first loop, we call our work function number 1 it's going to be. So we jump from here down to here. This instantly returns and calls out a return integer function by writing this value into this pass structure. Let's look at the function. So in here we're just setting the data type to, in this case, 1, which we've just, for our demonstration purposes, just means that the return type is integer. So when we look at this thing, we look at the type first, and then we read which value or string it happens to be. If we call return float, we're setting it to type 2 and putting our float in the float field. Same as string. Now you can have arrays being returned or pointers or whatever you wanted to, right? You get quite complicated if you wanted to. So these are the return functions that you would call. I'm not saying use this exact code. This is a principle that you could use. So all of your functions that have been dynamically called could have, could return one of these patterns like normal, instead of just having, a return value of 100. Those familiar with PlayBASIC will understand that, but if you're not, go look into how functions work in PlayBASIC. Right, so if we follow our little execution path through, we've got work function 1, we're setting the type of return value to integer and setting the value that we want to return as 100. Then returning back to after where the call function was made, and then we're looking at the return value here and adding it together as a string. And down here, I made a little function that just does this very basic thing. Let's get return. So we're looking at our data type. If it's 1, we read the integer field. If it's 2, we read the floating point field. If it's 3, we return the string. So what you could have is like, a function, you could just call it get type, I guess. So we might pass the thing in and then have the result here. We'd be doing that for readability, but we might actually have in here too let's just check that what's being passed in, this output pointer, is not something, it's not 0. Right. Now I'm using pointers here. You don't even need to do that. You can have this as this could be just a typed array, a typed variable at the top of the program. That would mean we don't even have to pass it in when we call it. We're just we're setting the data for return. If you wanted to have multiple levels of calls, you'll need to have a stack, but we don't need this for this situation here. In most, I tend to use call function in this kind of behavior when I want to do interfaces or GUIs in general. So where I've got one piece of code that needs to then, when a user clicks something or types something or whatever, the code calls a function to act out that behavior. So if it's a menu and the user is hovering over something and they click on it, then we want the interface to then call the function for us to do that action. So we don't need to have like a select case statement or a bunch of if statements to work out, all right, the person clicked this menu item number 3 or whatever it's going to be, what function or what subroutine do I then call to do that thing? Like, maybe they click the load option in your menu and you want to call a function that opens a open file dialog and then loads the media that you want to load. Yeah, we're getting off track there, but yeah. So we don't actually need to pass these things around. I've just done it like that for an example. Let's have a look. As you can see, it's called function number 1. That function returned an integer of 100. Called function number 2 returns a float of 1, 2, 3, 4, 5, 6. Next, function 3 calls our myString with a random number on the end. And that just repeats. They're just wrapped. We're just calling the same 3 functions. We could just call it randomly, I guess, but it's one way of doing this return stuff. Well, you could get rid of this thing here. This wouldn't need to be a pointer. We might have it like call function result, let's say. We don't get rid of this. Just make sure that's allocated. So inside these functions, inside these worker functions here, we would just have this. We don't need the input data. It's probably a bit cleaner. It's a little bit less for the person to keep track of. Get our return type. It's just going to be, hey, check this thing here. We don't need this. Get return, get rid of that thing. Use out. You could wrap that in there, I guess, if you wanted to. Get a return type. There we go. All that's the same. I think I'll just use search and replace from then on. Thanks. Do a replace of output dot. And we'll replace that with our global function. Call function result, replace all. Yeah, do all of them, thanks. Right, we don't need to pass this in anymore. I'm just going to push the float out or drop the float onto it. There. Get return. Oh, I'm missing a bracket there. We've cut that off at some point. Don't need to pass this in anymore. Oh, sorry, don't need that. There you go. Because this structure up here this variable is being created at the top of our program, and then we're no longer destroying it or touching it. We can just call those right to it whenever we want throughout the program. So effectively, we can act as our return structure without having to pass the structure in. Now, you might want to have, a list of these things. That's a more complicated thing to do, and have a list. Then every time we go to call something, put information on this thing here when we write back to it. We would have like in here, for example, you could go, hey, create a new one of these, which puts it on the head of the stack pretty much. the list. So when we pop it off or retrieve the head later on, we've got that that initial value. That's only really necessary if you need, functions within functions being called. So if you need the return data from something else to be preserved, which in most instances I find that you generally don't. Occasionally you might need that, but for most programs, this kind of structure or this kind of pattern works pretty well. And it does away with the need, with any needs of what we're returning. And this function here, or these functions, can be sort of largely agnostic, so they can return it whatever you want. Even your parameters here, you could have a push mechanism to push a bunch of parameters onto a list. Let's say of this same type, you call your function, and inside the function, it then goes through the list and grabs the values out that it needs, probably by name, which is, it's a bit clumsy, but that would really separate the two things from each other. We might make a second video to try and do something like that. But for now, that's all I want to talk about. Thanks for watching, coders, and enjoy your development progress, and I'll see you next time. Bye.